Okay, like I was saying in the other videos about the closure property, that after solving, they will give us definitions, and after solving, so we should be able to find all our answers in the questions back. If you cannot find it there, that means the operation is not closed. Okay, look at it. They say a non-empty set X is said to be closed. That means it's said to be closed under a binary operations asterisk if all the elements of X can still be found back in X. If all the elements of X after we have solved it can still be found back on this operation. Now let's take a look at example. Don't forget they said a non-empty set. Don't forget that in binary operations we are dealing with set that is not empty. Because once it is empty, we cannot be able to define it. Okay? Now, let's take a look at this example for the closure property. It says an operations for all is defined on the set this. Set of X of this element. By this, they give us the definition. This is the definition. X for all y equals to X plus y minus xy. This is the definition. They say we should find this and know whether the operation is closed. We want to test whether the operation is closed. Now, for the first one, we are given 2 for all 5. 2 operation 5. That is 2. Anywhere I see X, I'll put 2. Anywhere I see 5, I'll put Y. So I see X 2 plus 5 minus 2 times 5. 2 plus 5, that is 7 minus 2 times 5, that is 10. 7 minus 10, that is minus 3. Now, check for the second one. 0 is a 4. That is 0 plus 4 minus 0 times 4. 4 minus 0 times 4 is 0. 4 minus 0, that is 4. Now check for 3. 4, 1. So 3 plus 1 minus 3 times 1. 4 minus 3. That's 1. Check for the last one. The last one says 4 is 5. That is 4 plus 5 minus 4 times 5. 4 plus 5, that is 9 minus 4 times 5, 20. So 9 minus 20, that is minus 11. Now, if you check all the answers you got, the first answer is 4. The second answer is the first answer is minus 3. The second answer is 4. The third answer is 1. The fourth answer is minus 11. Now we want to know whether the operation is closed. Now go back to the element given. We have 4, we have 1, but we don't have minus 3 and we don't have minus 11. We don't have minus 3 in this element and we don't have minus 11. Definitely this operation is not closed. This operation X is not closed. It's not closed because if it is closed, everything we are going to get we must be able to find them in this element given to us. It shows that the operation is not closed. That is what all about the closure. And if it can be in tabular, go and check watch all these videos, the tabular ones that we have done. Even though they ask you that, is the operation closed? Check the answers you arrive at and check the table. If there's a contradiction, maybe you have what you got as your answers, there are some ones that are existing there that is not found in that your tabular. That means the operation is not closed. It's not closed. Are you getting that?
Yes, sir.
Okay. Now we want to check the commutative property of binary operation. Without wasting our time, when they say something is commutative in mathematics, what does That means, let's say if I put A plus B, for A plus B to be commutative in mathematics, that means B plus A, they must be the same. Now let's use number to check. If I say 2 plus 3 and 3 plus 2, are they the same? Yes. 2 plus 3 is 5. 3 plus 2 is still 5. That means it is commutative. Now, that means addition is commutative. If I say 7 plus 3 all over 2 and 3 plus 7 all over 2, no, 7 plus 3 is 10 all over 2 is 5. And 3 plus 7 is also 10 all over 2 is also 4. That means it's still commutative. It's still commutative. Now let's check whether subtraction is commutative. If I say 7 minus 2 and 2 minus 7, actually 7 minus 2 is 5. 2 minus 7 is minus 5. Is it commutative? No. That means subtractions is not commutative. Because if I do it from the right, I should be able to get it back from the back, from the front and back. So this one, subtraction is not commutative. Let's check whether multiplication is commutative. If I say 7 times 2 and 2 times 7, 7 times 2, that is 14. 2 times 7 is still 14. That means additions and multiplications, they are commutative. Division can never be commutative. I think you know that one. If I say 8 over 2 and 2 over 8, this one is 4, while this one is 1 over 4. So they are not the same thing. So divisions is not commutative. That means additions and multiplications, they are commutative. Now let's check what is on the board. It says the operations circle on the set R of real numbers is defined by this. They give us definitions. A circle B equals to A plus B all over 2 plus AB plus AB for the element of, for the members of the element of this R. The members of R. Show that the operation is commutative on R. Now, for the operation to be commutative, I know we have said that addition is commutative. That means if A circle B is this, that means B circle A, which is going to be B plus A, B comes for Z, A comes for Z. B plus A all over 2 plus B A. Now, if I use number, you will know that truly it is commutative. Let's say, let me call this one 2, let me call this one 3. If I call A to be 2, B to be 3, if I put that 2 here, 2, or let me just call this one 4, let me call this one 2. That is 4 plus 2, 6. 6 all over 2 plus 4 times 2, 8. All over 1. 2 in 6, that is 3. 8 by 1, 8. 8 plus 3, that is 11. Now don't forget, B is 2, A is 4. 2 and 4. That means if I put 2 here, 2 plus 4 is still 6. 6 divided by 2, that is 3. Plus, what's B? 2. 2 times 4, 8. 3 plus 8 is still 11. That means they ask us to show that the operation is commutative. Yes, on R. The operation circle is commutative on R. It's actually commutative because they are the same. That means the operations is commutative on R. Now let's check associative. Now this is, don't forget to define binary operations. I said binary operation has many properties. Don't forget, and we've talked about the closure properties, we've talked about the commutative property, we won't talk about the associative property. Now, X is closed under a binary operations asterisk, then A and B is the members or element of X, implies that A asterisk B is the element of X. Fine. And A asterisk B can also combine with C as it's also the element of X. Now, what does that mean? Now, when something is associative, like if I have 2 plus 3, it's not associative, it's still under commutative. I must be able to combine it with another number. So, it's telling me that associate, that means associate. Now, I must be able to now write it like this to get the same answer for me to know that truly it is associative. Like 2, if I bring the 2 outside, plus 3 plus 4. If I get the same thing, that means this thing is associative. If I don't get the same answer, that means addition is not associative. For me to know whether addition is associative, if I get this answer like 2 plus 3, 5. 5 plus 4, 9. 3 plus 4, 7. 7 plus 2, 9. That means addition is associative. Now let's check it for the multiplication. Said can also combine with C. That is the C I'm putting outside. If I say 2 times 3 can also be combined with, let me say, times 4. And if I also write it like 2 times open bracket 3 times 4. If I can get the same answer, that means multiplication is also associative. 2 times 3, 6. And 6 times 4, 24. 3 times 4, 12.